We have covered all parts of the supervised learning workflow. But how do we decide which model to use in the first place? This is a complex question, and the answer depends on our situation. There are some principles that we can guide us when making this decision. The size of our dataset plays a role. Fewer features means a simple model and can reduce training time. Also, some models such as artificial neural networks requires a lot of data to perform well. We may need a interpretable model. So we can explain to stakeholders how predictions were made. An example in linear regression where we can calculate and interpret the model to coefficients. Alternatively, flexibility might be important to get the most accurate predictions. Generally, the flexible models make fewer assumptions about the data. For example, a KNN model does not assume a linear relationship between the features and the target. Notice the scikit-learn allows the same methods to be used for most models. This makes it easy to compare the regression models. Then models can be evaluated using the root mean squared error or the R-squared value. Likewise, classification models can all be analyzed using accuracy, a confusion matrix and its associated matrix are the ROC AUC. Therefore, one approach is to select several models and a metric, then evaluate their performance without any form of hyperparameter tuning. Recall that the performance of some models such as KNN, linear regression, and logistic regression are affected by scaling our data. Therefore, it is generally best to scale our data before evaluating models out of the box. So, we will evaluate 3 models for the binary classification of some gender, KNN, logistic regression, and a model called a decision tree classifier. We import our required models, include decision tree classifier from scikit-learn.tree. The working of decision trees are outside of the scope of this course, but these steps of building this model are the same as for other models in scikit-learn. As usual, we create our features and target arrays, then split our data. We then scale our feature using the scalars dot fit transfer method on the training set and the dot transfer method on the test set. We create a dictionary with our models names as strings for these keys and initiate models as the dictionary values. We also create an empty list to store the results. We loop through the models in our models dictionary using its dot values method. Inside the loop, we initiate a K4 object. Next, we perform cross-validation using the model being iterated along with our scale training features. And target training array. We set a CV to equal to our K4 variable. By default, the scoring here will be accuracy. We then append the cross-validation result to our result list. Lastly, outside of loop, we create a box plot for our results and set the label argument equal to a uh, call of the model dot keys to retrieve each model's name. So this is the box plot. The output shows as the range of cross-validation accuracy scores. We can also see each model's medium across validation score represented by the orange line in the each box. We can see logistic regression has the best medium score. To evaluate on the test set, we look through the names and values of the dictionary using the dot items method. Instead, inside the loop, we feed the model. We feed the model. We feed the model, calculate the accuracy and print it. Logistic regression performs best for this problem if we using accuracy as metric. So logistic regression is 84% accuracy. Now let's choose which model to optimize our for our supervised problems. So again, I choose the which is white wine data, and there I took the X and Y. Then we choose the linear regression, ridge and lasso regression. Three these things regression models. So we split the training and test set, and we iterate the values and k-fold, and this is the cross-val score, append this value. So once I append this one, so linear regression, ridge regressions are good, but compared to lasso is not good. Then we will calculate the RMSE. So compared to list lasso test RMSE, remaining to our linear regression and ridge regression are better than this lasso. So that is about the decision, evaluating classification and evaluating the regression models. And thank you. We will connect in another session. Bye-bye.